Good morning to all. I'm Rajitha, working as Assistant Professor of Artificial Intelligence and Data Science Department in SNS College of Engineering. We're going to see about fundamental of data science and analytics. Let's move on to the subtopic that is presenting and building applications. Data science is the field that combines statistics, machine learning, and programs to extract knowledge and insights from structured and unstructured data. Building and presenting application in data science is a crucial skill for professional in the field. The goal is not only to create a working solution but also to effectively communicate the finding and how the application can solve real world problem and defining the problem and before jumping into any technical solution, defining the problem clearly is the first step in building a data science application. A well defined problem serves as the foundation for the entire application, providing direction for the data collection, analysis, and modeling. Understanding the business objective. Data science often collaborate with business stakeholders to understand their objectives. A business might want to predict customer churn, forecast sales, recommend products, or detect fraud. It is essential to ensure that the data science application align with these business goals. Formatting the problem. Once the objective is clear, the next step is to translate the business problem into a technical problem. This involves defining the type of data required, the kind of machine learning model needed, or the analytics method to be applied. Data comes in different formats: structured data, semi structured data, and unstructured data. In this phase, data scientists either collecting existing data, scrap data from the web, or work with business teams or to assess internal data sets. And the data cleaning and processing is data collected is rarely in a usable state and must undergo cleaning and pre-processing. This includes handling missing values, removing duplicates, and ensuring the data in the right format. Techniques like normalization, scaling, and encoding categorical variables are essential for many machine learning algorithms. Feature engineering involves selecting and transforming raw data into the feature that better represent the underlying patterns for predictive modeling. This might involve creating new features based on domain knowledge or applying dimensionality reduction techniques like PCA, that is principal component analysis. And the report is generate detailed report summarizing methodology, finding and actionable insights, include key metrics, model performance, and limitation for transparency. Reports can help stakeholders understanding the models result in these documents ensure clarity and serve as a reference for future decision making. And the model building is the selection of an algorithm depends on the problem type. For regression task, algorithm like linear regression or decision tree might be appropriate. For a classification, options include logistic regression, SVM, random forest, or neural network. It is important to understand the assumption and limitation of each algorithm. Training a model involves splitting the data set into training and testing set. The model is then trained on the training set, and the parameter are fine tuned using techniques like grid search or random search to optimize performance. And the combine data insights with the compelling narrative for better engagement. Use relatable examples to connect technical results with business goals. For example, investing thousand hundred rupees in marketing is projected to increase sales by rupees 400. A storytelling makes the data more relevant and memorable for stakeholders. And the building application is building a data science application often requires combining multiple technologies. Common stack include backend Python, Flask, Django, or Fast API, and frontend, if needed, HTML, CSS, JavaScript, React, or Dashboard. Databases, SQL, MongoDB, or cloud services. Deployment scaling. To make the applications available for real world use, the model must be deployed. This might involve using cloud platform like AWS, Google Cloud, or Azure to deploy the model and ensure scalability. Dockers, container, and Kubernetes are often used to make deployment more efficient. For many applications, exposing the models as an API is essential. This allows user or other system to make prediction in real time. Presentation of results. The ability to do present data science result effectively is just as important as building the applications itself. A successful presentation can drive decision, attract stakeholders, or educate the audience. And the conclusion is building and presenting data science application is a process that blends technical skills with effective communication by focusing on a well-defined problem, choosing the right models and technologies, and presenting results clearly. Data scientists can create solutions that drive business outcomes. Thank you.